Hey there, and welcome to Into the Terminal episode 34. I'm Eric the IT Guy Hendricks, and joining me every single episode is my co-host in crime, Mr. Scott McBrien. Today we're
Hello.
going to go back and look at some content that we covered in episode 2, and we're going to take that a step deeper. So today we're going to be looking at file permissions, but how can you set file permissions at a deeper level? How can you use things like setgid, setuid? Everybody loves a good sticky bit, and some ACLs. So with that said, we have a jam-packed episode and only 30 minutes to get through it all. So why don't we go ahead and dive into the terminal? So we have our basic RHEL 9 lab, and we've created some files. So why don't we start out with just an ls-l and see what we're working with here. So we've got a number of different test directories, and we're in a directory called perm test. So the first thing we want to look at is the setuid. So this allows you to basically to allow a user to run as another user. It's not like sudo. It's different than that. This is at the file permission level. So if you were to create a file using setuid, it would then inherit that set user ID. So why don't we go ahead and start with an example? I think it'd be easier to walk through with an example here. So let's take a look at the permissions on the password utility. So passwd. You notice that we've got an S in that first octet there. What that means is that there is a setuid in place. And a setuid, when applied to a compiled binary executable file, it'll switch the effective user ID. Yes, I'm reading this off the man page of the person running the application from their normal ID to the ID of the owner of the file. So if we're using the password command, you notice that we're going to be running this command as root. So why don't we look at another example and do an ls-l on the umount command in the same directory. So we can see that both of these utilities have a setuid for the root user. And so why don't we use the chmod command on one of our test files, and let's do a chmod on u plus s. So if you remember, when we're doing file permissions, you've got the user, you've got group, and then you've got other. So what we're going to do is we're going to set uid on test file 1 using u plus s. So now you notice that we've got that capital S there, and that now our test file 1 is owned by root, but we've set that set UID. The other way to go about doing this is with the numerical permission changes. So let's do that on test file 2. So to do that, we'll use chmod 4555 on test file 2. So I know that was kind of a whirlwind example, but Scott, you want to kind of add a little extra color to what we're doing with this?
Yeah, so a couple of things. One is, as Eric points out, it only applies to compiled binary executables. Right? These test files that I'm trying out, they are not compiled binary executables. So even though we can use chmod to set SUID bit on these, it doesn't actually do anything special. You'll also notice that with our ls output, that once the SUID is in place, it shows the file as red. That's to let you know that there's this additional special permission. And then with the examples that Eric showed earlier, right, specifically user bin password. So the reason that we allow someone to run this command and temporarily elevate their permissions to root is because if you think about what's happening with the password command, you're being asked for your password and asked for it again, and then it's going to update a bunch of files like Etsy Shadow. And who has permissions to modify Etsy Shadow? Technically no one, but permissions don't apply to root. So by elevating your effective user ID when running the password command to be root, you're able to then put additional data in this, non-accessible file of Etsy Shadow. So that's the goal with with SUID is to temporarily switch you during the execution of a program to somebody else so that you can perform tasks or access things that normally under your normal user ID you would not be able to access or do.
So with our group permissions, or with user permissions, a lot of these same processes and a lot of these same concepts apply to groups as well. So just like we have a set UID, we also have a set GID. So if we were to, let's go ahead and do another long listing here so we can see what we're working with. Generally, the set GID is used to allow users to execute a specific command and temporarily modify their effective group ID during the execution of that command. So yes, I am reading right off the man page today just because explaining what set GID and set UID and particularly sticky bit has never been a forte of mine. It usually takes a number of examples before I can explain what this is and how it works. So let's take a look here at one of our binary executables again. This time, let's do an ls-l on user bin write. And so we don't see set UID nearly as often as we see set GID. But you notice in the group string on our permissions here, we've got that lowercase s just like we saw before. So why don't we go ahead and change a couple of our test directories here to match? Let's do a chmod g plus s just like we did before on tester A. So that's how you do a set GID. And then using characters, and then we can do a if it works. There it is.
Helps if you spell it right.
And that usually helps. And then just like before, we can do a chmod 2775 on tester-b and do that, basically make that same change with the numerical approach as well. So notice that in both examples we have a lowercase s in the G or in the group segment of those permissions.
So if I could tag in here for a second, Eric.
Yeah, please.
When we look at user bin write, so just like we saw with the SUID permission on a compiled binary executable, what happens is when you run the write command, you become the TTY group, right? And it turns out the TTY group allows you to do things like access the TTY devices, right? So if we do a ls-l on dev y 0, see how people who belong to the TTY group have write permission on these TTY devices. Well, these TTY devices are tied to the different text consoles on your machine. And when you use the write command, oops, sorry, and you tell it, actually, let's use wall. Wall's another good one. And it's not working on my SSH session. Pooh. So what it does is it takes that text and it will send it to these TTY files. And because you belong to the TTY group, you're allowed to write that text to these TTY devices. And so that's how that's functioning. But when we did our perm test here on tester A and tester B right here, the SGID bit does something different when applied to a directory. So when applied to a compiled binary executable, temporarily switches your group ID to be the one that owns the executable file. But if it's on a group, it does something a little bit different. I was waiting for Eric to tag in, but he's going to let me.
Sorry, I was looking ahead in our notes. So that's set UID and set GID. There's kind of a third there's a third concept here that we want to cover, and that's the sticky bit. And Scott, after like 15 years of working in Linux, I still cannot put together a coherent explanation of what sticky bit is. I know how to use it and when to use it, but trying to explain that to another human being in plain English, never been something I've been great at.
So we can see it here on both the temp and var temp directories. And originally this was called the tacky bit, but nobody likes working on tacky operating systems, so it was renamed to sticky. However, the T is still what we use as the iconography for sticky bit. Typically, it's applied to shared directories where a lot of people have write access. And you'll remember that write access on a directory lets you add or delete files from that directory. But with the sticky bit applied, it says that the write permission allows you to add whatever files you want to a directory. However, it modifies that ability to remove files. If the directory is sticky, only the owner of the file can delete it. Right. So I've got a couple of users here on the system. All right. So Joe put this file in temp, and as this alternate user, Sally, she has access to temp, and she can according to these permissions, she can read Joe's file. But if she tries to remove it, it won't allow it to happen because Sally doesn't own the file in this stickied directory. So sticky permission on directory usually apply to public or very widely accessible, very widely writable directories like temp or var temp. Says if someone puts a file in there, they're the only person that can remove the file back out again. The one exception of that is the owner of the directory can also remove it. So in the case of temp and var temp, that would be root, could also remove those files.
So Setuid, Setgid, and StickyBit, three great tools to have in your toolkit. And we'll look at another example as well as ACLs in the bottom half of the show.
And before we go, Eric, we need to do the chmod for sticky. So,
oh gosh, yeah.
So we could do O plus T that lives in the others field, or we could do a chmod of 1777. And we can see that here, there's my O plus T, there's my chmod 1777 that gave me the SGID directory.
Yeah, it definitely helps if you actually apply the command. It is lunchtime here at Into the Terminal. All right, let's dive into to the second half of the show. Okay, so we had another example for setgid, and so we had some pre-built examples that in the top half of the show just kind of walk things through. But what is a real world scenario if we wanted to use this on a shared Linux system? We kind of devised a bit of a scenario. So why don't we go ahead and create let's create a new group, and let's call that group student. We're going to go back to school. And then we can add one of our sample accounts or the RHEL account into the student group. So RHEL is now a student. And then let's go ahead and create a directory that we'll use for sharing. So let's create a school directory here out on root, and then we can add, say, like econ 101 for one of our classes. Let's throw some files in there to see what happens when we just create files as the root account.
HGRP. You spelled the command correctly.
So now we've got a school directory that's owned by root and owned by the student group. And then we've got a class in there with the same permissions. So anyone taking Econ 101, extra points for you today. And then we'll create some sample files in the Econ directory. So maybe a test that you have to take, some report that you're writing, maybe some class notes. So now if we do an ls-l on the Econ 101 directory, I would expect to see just our current user accounts permissions. So these files will be owned by root. And because root's primary group is also root, we see the group root owns these files. Try and say that 5 times fast. But we don't want root to own these files. We want to be able to share these files with the teacher, with other students. So we want these files to be owned by the student group. So we could go in there, and every time we create a file, we could do a group and change the permissions. But we're talented systems administrators, so we don't want to have to do that every single time we create a file. So instead, we can actually set that on the directory, and that's where that setgid command comes in. So if we do a chmod g+s on the econ 101 directory, I have no idea what's going on downstairs. Hopefully no one hears that. Okay, so now we set the setgid. So one thing to note is this does not change the permission set on existing files. So we will have to go in there and, as a one-time thing, do a group on the existing files. So we changed the group on the notes file manually. We can go ahead and do that on the other 2 files in here, just so that all of our permissions are set the same. So if we do a group student on any files now from here on out, we've set the setgid on the directory, and we've changed the existing files. So now this is where the power of setgid comes in. So let's say we've gone through a couple more classes, and it's time for our next test, and we've written another report. So if we create a couple more files, I think we'll see something pretty awesome in the directory. So if we create a couple more files, and then we look at that directory again, we notice that test 2 and report 2 already have that group of student preset. So there's anything that's created in this directory from here on out, we won't have to change the permissions on. It'll be available to anyone within the student group. Excuse me. So that's kind of where setgid and setuid and stickybit come into play. But there's also something else. There's the read, write, execute on user group and other. That's not to the extent of the permissions within Unix and Linux systems. There's also ACLs, access control lists. And this is where you can get really deep into really customizing who can do what action on particular set of files. So Scott, do you want to kind of explain the scenario you've set up for us?
Sure. So using things like SGID is really handy if you're able to create groups and change memberships in groups, so that when you have this kind of shared area for files, they automatically get group owned by the correct group so that other members can share and collaborate on files. But what happens if you're in an environment where you don't have that very hierarchical group structure defined, or you rely on another group to manage accounts and settings, or you're using an alternate authentication framework so that it's difficult to like get groups and people in groups and things like that without help desk tickets or whatever else. So that's where access control lists really shine. Access control lists are a supplement to our existing user group other permission scheme. And it allows you to set specific permissions for a specific user or a specific group on a file or directory. So I created a few users before the show. We have Ramesh, Joe, and Sally. And so I'm just going to become Ramesh here. And Ramesh is going to create a directory structure for himself. Right, so here's my directory Ramesh data. And he's going to set an access control list on this directory. All right. So I did a couple of things. One is I set the file access control list, setfacl. I used -d to tell me that I was setting this on a directory. And that's important because if it's set on a directory, newly created files in this directory will also inherit this access control list. I wanted to modify the access control list, and here's how I want to modify it. The user, Sally, should get read, write, and execute on this directory. All right, if I do a getfacl on var 10 mesh data, I can now see that these access control lists have been set as the default, right? So they'll be passed down to additional subdirectories created in here or additional files created. All right, so next I'm going to create some files in Ramesh's directory. All right, and then we're just going to list them. Right, so there they are, the 3 files I created, but you'll notice something a little bit different about those permissions. Specifically, there's a little plus sign here. That tells me that there's more stuff than what's being defined or shown in the permissions on these files. So if I do a getfacl on data 1, for example, I can see that the user Sally has been given read, write, and execute permission, although it's effectively read and write permission according to the getfacl command. So that means that if Sally comes into this directory, she can read and write this file, even though, according to its file permissions, she would be treated as an other because she's not a Ramesh user or part of the Ramesh group. So she would have read-only permissions. But thanks to me adding this access control list for her, she can read and write this file. So if I get out of here and become Sally, right here I am in Ramesh's data directory, and I can edit .1. Right, so Sally has write permission, even though, again, normally she'd be treated as an other, but thanks to my access control list, which grants specifically Sally read and write, we're good. All right, but what about another user? What if I come in as Joe? Notice when I come into the file as Joe, I'm told that this file is read-only for Joe. And if I actually put in some changes, right, it won't let me write my changes because for Joe, who is not covered under the access control lists and is treated as an other on this file, read-only. All right, so let me go back to being Sally. Oops. Ramesh needs to add it to the directory. I'll just do it as root. So I just created this new file owned by Sally, Sally data 1. Right, there you go. You can see that the normal file permissions for user group and other are applied. And because it was created in this remesh directory, if I do a get facl on it, there is an access control list which covers Sally, who already was given user permissions as the owner anyway. But because Sally owns this file, she can also set her own file access control list on it. Right, so Sally is the owner of the file. She can change the permissions on the file, but she can also add her own access control lists. So on this file, Joe is now granted read-write permission, but on the other files in this directory that we didn't add this explicit Joe permission, it's still read-only for Joe. So if I become Joe again, I can edit Sally data as Joe. Right, no problems. But if I try to go into Ramesh's data 1 file, I notice that is still kept read-only to me because I'm covered under the normal file permissions because I don't have his access control list, granting Joe additional permissions beyond the normal. Right, so individual users can set their own set of permissions that apply to specific users or specific groups outside of the user group and other standard permission model. And that's a little bit on access control lists.
So one of the questions that folks may be asking is, when would you use like a set GID versus ACLs?
Good question. So I would say probably SGID is excellent when you have the ability to create shared groups and manage users as part of those shared groups. And there's a well-defined understanding of what those groups do and how they share files with each other. Right, access control lists is much more individualized and it's controlled by the users themselves. So if you are not as centrally managed, where you don't have the ability to create groups and add users to groups and know how the groups relate to each other, access control lists give you that individualized ability to grant a specific person access, but deny a specific other user access. We can also do things like remove people's ability to get anything even beyond their normal granted permissions. So for example, if I'm Ramesh, and let's take a look at the screen share again. If I'm Ramesh, and I'm like, you know what? Joe should not have access to data 3. None. You can't even look at it.
Yeah, we don't like Joe anyway.
It's been a minute since I've done it. All right, so let's do a get FACL out of 3. Right, so now the way it reads is if you're the user owner who owns this file, you're given read write. If you're Sally, you get read write execute. If you're Joe, you get nothing. And if you are none of those 3 people, if you're in the group owner of the file, which is the Ramesh group, you get read execute. And if you're an other, you would get read only. So just like normal permissions, we check to see if you're in the user access control list first. And if so, we apply those and stop looking. If you're not listed there, we'll check to see if you're covered in the group. And if so, we apply them and stop looking. And if you are neither covered in the user fields or the group fields, then you're treated as an other and you get the other's permissions.
And then we did have one other question in the chat that I wanted to up level here, and that was from Shantanu asking about the chmod command. Do we need to include that leading zero, or is that necessary or not?
Yeah, so in our earlier episode, we were talking about permissions. We used 3-digit permissions, right? So we do something like chmod 755. And it turns out that when you only specify 3 digits, you're actually specifying 4 digits. The fourth one is just implied. So if you provide only 3 digits, it will apply a leading fourth zero, meaning that if you had special permissions on that file, they get turned off. So the rule of thumb is if you're working with special permissions, always use 4 digits. And that includes when you're modifying the permissions, you probably want to use 4 digits. Or if you use the symbolic notation, like U plus, G plus, O plus, or minus, there it's taking the existing permissions and just making a specific change. And it'll take care of doing the numeric permissions automatically for you. Right. So all the time you've been using 3-digit permissions, you've actually been using 4-digit permissions. And today you learned that.
That was a great question, and we love taking your questions live on air. It's always fun to see Scott react quickly on his feet. So that kind of wraps up our deeper dive into file permissions. If you want to kind of look back at user and group permissions, that would be episode 2, and we'll have a link in the show notes for that. Glad to see a lot of our regular crowd joining us on a Friday around lunchtime. So I think the new time slot's working, and once folks kind of get back into their usual routine once summer vacations and everything wrap up, I'm really excited to see more of you all join us Fridays. So definitely like this content. The YouTube algorithm seems to be doing its job and bringing folks in to check out this content. So definitely like it, share it with a friend. If you have any suggestions for new content, new episode ideas, by all means send them in. Put your questions in the comments, and join us next week. So a week from today at 12 Eastern, we'll be talking about application streams. So sort of a deeper dive into package management, a different way to manage your packages and your workloads, version numbers, all that kind of stuff. So with application streams next week. In the meantime, on behalf of Scott McBrien, the entire Red Hat Enterprise team, and myself, Eric the IT guy, we look forward to seeing you all next week. Thanks for joining us.